Thanks for tuning in. This is Learning Target 9 and 10 student notes. We're going to be filling out these notes from your note packet, so make sure you have this out to this page. I'm not exactly sure what page it is. I don't have a note packet with me. And also make sure you have out your yellow handbook because we're going to be filling out some formulas on there for volume. Yeah, so let's get started. I am recording this on my phone. It's a little bit janky, but it's all we got, and I don't have an iPad/Apple Pencil at my house, so I'm just going to be using good old-fashioned pen and paper. Okay, so we are learning about the volume of prisms, cylinders, pyramids, and cones, and if you watched the video before this, I explained what those differences are, but especially between prisms and pyramids. I think that is pretty confusing. And when we filled out, if you guys remember this picture from that website, that goes into that a little bit. If you can see from here, these prisms have two parallel bases, right? And they extend out that way. And these pyramids all come to a point. What we can know about the volume formulas for these is prisms is just volume equals the area of the base times the height, okay? Where in pyramids, volume equals 1/3 area of base times the height. And notice how the area of the base, I am denoting that as a capital B. So we can write up here, capital B equals area of base. Where before, when we were talking about area, we were just doing lowercase area equals base times height. This is not to be confused with this, because this is a capital B, this is a lowercase b. This means the length of the base, where the capital B means the area of the base. So this is combining what we've learned about area to find the volume. So make sure we have this in our handbook for prisms and pyramids. Pyramids volume is 1/3 area of the base times the height. Sometimes that area of the base is going to be a triangle. It can be a rectangle, it can be a square, it can be a pentagon, it can be any of those things, but we just need to know general area of base. Same idea for prisms, except instead of 1/3 area of base times height, it's just area of the base times the height. So here we have just more shapes that we will be looking at. We have rectangular prisms, spheres, square pyramids, triangular pyramid, etc. So let's look. Here we have another definition of pyramid, prisms, and cones. Once again, we can write volume equals 1/3 area of base times height. And the exact same thing for a cone. As you can see, cones are virtually rounded pyramids, right? So this is also volume equals 1/3 area of the base times height, but the area of the base in a cone is always a circle. So we can be even more specific than that. So think for a second, what is the formula? What would the formula be for the area of this base if it's just a circle with the radius r? Yeah, so the formula for the area of this base is just pi r squared, right? Because that's the formula for the area of a circle. So instead of saying 1/3 area of the base times height, we can just say 1/3 pi r squared times height. Makes sense, right? And then prism, again, is just volume equals area of the base times height. And I think a lot of these are also in your state reference sheets, which you can find linked on Schoology if you guys want to reference that. Not that we're taking state testing anymore, but okay. So let's apply what we learned. Also, really quick, I mentioned this in the video before, but we have two different kinds of heights with pyramids specifically. We have slant height, which runs along the side, and altitude, or the actual height, which is perpendicular to the base. When we are plugging into our formula for h, we are talking about this height right here, not the slant height. We do not want to use slant height when we're plugging in for h. Okay, so sometimes we're going to have to solve for this height, which we will see in the problems to come. But to reiterate, we need to make sure we're using this height, not this height. Okay? Cool. Let's start our first example problem. Draw a picture of a cylinder with a height of 12 inches and a circumference of a circular base of 6 pi. What is the volume of the cylinder? So cylinder, think. Does that fall under more of a pyramid or more of a prism? we're talking cylinder. I draw two kind of elongated circles, connect the sides like this. There we go, that's my cylinder. That's more of that prism, right? We have two parallel bases, that we can't call it a prism because it's circular, so we call it a cylinder. So this volume formula equals area of base times height, not the 1/3, right? Because it has those two parallel bases. So we can do pi r squared times height, right? Because we know the area of the base is just pi r squared. So now we have to solve for those values for r and h to find the volume. And what information does this problem give us? It already gives us height of 12 inches. So we can write over here, h equals 12. And a circumference of a circular base of 6 pi. So it's giving us the circumference, but we need the radius, right? So think for a second, pause, think, see if you can figure out how you can use the circumference to find the radius. Okay, so we know the formula for circumference is 2 pi r, right? That's on our reference sheet. We've learned that in previous learning targets, right? So we know the formula is 2 pi r, and then it's giving us a circumference. So we can plug in that for c equals 2 pi r, and just use this equation to solve for r. We divide by 2 pi on both sides. Those pi's cancel out, and we get 3 equals r. So we have 3 is r, h is 12. We just plug those bad boys into this equation, and we get v equals pi times 3 squared times 12, and this is telling us to give both exact and rounded answers. So exact is when we leave it in terms of pi. If we plug that into our calculator, we get 9 times 12 equals 108 pi. If we want the rounded answer, volume is approximately, and we just plug 108 second pi into our calculator, and that gives us approximately 339.3. And when we're talking about volume, we're talking about units to the 3rd power. So inches cubed. Inches cubed. Cool, let's move on to the next problem. Given a cone with circumference of 54 feet and a slant height of 9 feet, calculate the volume to the nearest tenth. So here we have a cone. Oh, that was terrible. And it has, so our formula first for cone is volume equals 1/3 area of base times height, or volume equals 1/3 pi r squared times height. Okay, so now we have to solve for what the radius is and for what the height is going to be, because this is giving us a slant height. So it's giving us this length right here, which is 9, okay? We need this height for h, the perpendicular to the base height, and we don't have this radius either. So we can use, just like before, this circumference to solve for the value of the radius. So circumference equals 2 pi r. We know circumference is 54, plug that in, 2 pi r. Solve for pi, divide by 2 pi on both, or solve for r. And we get r equals 54 divided by 2 pi. And that is, what in the world? Oh, okay. 54 divided by 2. Make sure you're plugging it in parentheses because we want it to be divided by the whole thing. We get 8.59 feet. That's the radius, okay? So that's this value right here, 8.59. And we want the height. Do you guys see how there is a right triangle right there? So we can use the Pythagorean theorem and solve for the height, right? So we have h squared plus 8.59 squared equals that hypotenuse 9 squared. And all we have to do is solve for h. We get 9 squared minus 8.59 squared. We get square root of 7.2 2119. The height is approximately 2.69 feet. So we have our radius, we have our height, we plug those into the volume formula, and pause it, plug that in, see what you get, and I'm gonna keep going. 8.59 squared times 2.69, and we get 1/3 times pi times 8.59 times 2.69. And you should get, the volume is about 207.9 feet cubed. Pretty good? Okay, we have two more problems. Find the volume of a square-based pyramid with a base perimeter of 24 centimeters and a slant height of 8 centimeters. So the volume of a square-based pyramid, we have a square pyramid like this. So a base of a square, and it comes to a point. It's giving us perimeter equals 24. Slant height equals 8. So right here, that equals 8. So we need to find the actual height and this value right here, right? Because we need to be able to solve for that height using the Pythagorean theorem. So it's giving us perimeter of 24. It's a square base, so we can just divide this by 4 to find one side length. 24 divided by 4 is 6. So if we multiply 6, 6 plus 6 plus 6 plus 6 is 24. That's the perimeter. That's what we're given. Easy. Then this height is going to hit directly in the middle of the square. So we know this value is 3. We have slant height 8. This is 3. If we pull this triangle out, we have this. With the slant height of 8, this half of one side length is 3. We need this height right here. So solve for that. Use Pythagorean theorem. Volume formula equals 1/3 times area of the base times height. So area of the base is length times width, right? And we solve for that length and width here. 6, 6, 6, 6. Okay. So solve that. You can check your answer with the filled out notes on Schoology. And last but not least, we're not going to go over this one, so do not worry about it. Find the volume of the sphere. Our volume formula for a sphere is 4/3 pi r to the third power. Okay, it's a little bit wonky, but just got to remember that. 4/3 pi r to the third power. Here we're given the diameter is 22. Easy, right? Diameter equals 2r. So if the diameter is 22, r equals 11. We just plug that into our calculator. 4/3 pi times 11 to the third. Plug that into your calculator, and you should get 4 divided by 3 times pi times 11 to the third, around 5575.3 inches to the third power. All right, that's all. Thanks for tuning in. Bye.